In this video, we're going to take a look at an animated overview of how Kotlin Co Routines work in Android. There's no code in this video, but we will have code in a video that follows this, so this is a good overview for a wide audience. Coroutines are introduced in Android to give us an easy way to perform threading. We've done threading in Android ever since the invention of Android, but it's been cumbersome before. We had to use the traditional Java syntax of runnables and threads at first, and then we used AsyncTask. Now coroutines make life a lot easier for us. Let's take a look at how they can be used. First of all, let's consider what it looks like if we don't thread. So we have process number one, which is some fast-running process on the user interface thread, something like a button click or rendering something on the page, something like that. Processes 2 and 3 are long-running processes like making a network connection, connecting to a database, or downloading an image, or something like that. And then number 4 again is a user interface event. If we didn't use threading at all, what would happen is we'd have our fast number 1 event occur, and then number 2 and number 3 would be slow, and during that time we couldn't respond to the user interface. And then finally we can respond and we see that event number 4 happens relatively quickly. So the moral of the story here is, if we didn't use multiple threads while we're doing a long-running process, we cannot respond to user interface events, and it looks like the device is frozen. And think about what happens when a user sees a frozen device. Many times they do the worst possible thing they can do, and they keep clicking and keep clicking, which only sends more events to this event thread. So, starting around Android version 4, which is many, many years ago, we were no longer allowed to do long-running processes on the UI thread. Believe it or not, in early Android, we actually could do it, and many times we would see non-responsive programs like this. So it's a good thing that they forced us to do things like network operations on a separate thread. So let's reset our processes, and let's see what happens when we introduce a coroutine verb called launch. Launch means take these long-running processes, run them on a separate thread, or think of it as a separate process. But launch is like a fire and forget. We're going to spawn these processes, we don't need to hear back from them, and the good news is that means as soon as they're in their separate thread, we can continue responding to user interface events. So, event number 1 happens, number 2 and 3 go to a separate thread, and you see number 4 is automatically able to work even as number 2 and 3 are running slowly in a separate thread. So that's launch. Launch is fire and forget. But what if we want to hear back from these processes that are long running? Let's reset again, and let's consider something called async and await. Async means we're going to invoke these two processes in a separate thread, but then we're going to put an await on them on number 4, which says we're going to wait for number 4 to happen until number 2 and 3 are complete. Let's watch how this happens. So event number 1 happens, it invokes async on 2 and 3. 2 and 3, notice, run simultaneously, and then they inform the await that they're done, and then number 4, which is awaiting on 2 and 3, can then process. Now you might say, what's the difference between this and running everything in one thread like the very first example? Because we still have to wait for 2 and 3 to finish. Well, the advantage here is 2 and 3 can run simultaneously, which means that we're speeding up the total amount of time that's processing, because 2 and 3 are essentially running in parallel. Now, what if something goes wrong with either 2 or 3 and number 4 is left waiting? Well, let's reset our processes again, and this is where Scope comes in. Scope manages our coroutines, and if something goes wrong, it can stop execution. So let's watch what happens. We have our first task. The first task calls async on 2 and 3 with the given scope. 2 and 3 process, but oh my gosh, there's an exception. Now it's going to stop both of them and report back the exception to the main thread. And then our number 4 process can decide what to do. So it's actually possible, if the exception was thrown from 2, that 3 can get notified that, hey, an exception happened, I can't go to completion. And then we essentially throw that back to the main thread and say, hey, something went wrong, decide what you want to do from here. We may want for it to continue. We might want to just inform the user or take some other action like so. So that's a look at the animation. Let's take a look at some keywords. Suspend is a keyword that we use on a function, and what that means is pause the current coroutine and save the stack state or in other words, the local variable values for later use. Resume means we're continuing a suspended function, and we're starting it from where it was suspended. In other words, we're reading those local variable values. Launch and async await, we just saw those on that previous navigation. Launch means start a brand new coroutine, fire and forget. Async is somewhat similar. Async means fire a new coroutine, but we have that option to put in a wait, where we're going to wait back when we hear from that async coroutine finished, and then we're going to take further action based on that. So with the wait, we essentially want to hear a result. From a launch, we don't need to hear a result. We might be just caching something in the background, which indeed that's an example that we're going to look at when we get to the code example. Dispatchers are telling us which thread to use for a coroutine. If you look back on the animation, you'll notice that I had my two dispatchers labeled. Dispatcher.Main, which is where I ran most of my UI events, and then Dispatcher.io, which is where I would run number 2 and number 3, the long-running processes. Dispatchers.Main is where we do a lot of our UI events, like LiveData. Remember, with LiveData, we have a user interface that is looking at something that it can observe, and as that thing changes, the UI updates automatically. Dispatchers.io is where we're going to do a lot of long-running read and write events, things like writing to a database, or reading from a network. Think like parsing JSON. Many times, we have to open a network connection, and then parse JSON, and then make that available. File.io, like maybe taking a picture, downloading the picture from the internet, saving it locally. Anything that's long-running like that will happen on Dispatchers.io. Then we have Dispatchers.Default, which is where we do things that are typically computational intensive or memory intensive, like sorting a long list or searching through a long list. We'll see when we put this in code that we're going to wrap this in a with context statement. Finally, we have that concept of Coroutine Scope. Once again, you remember our animation. The Coroutine Scope is this gray box where we put our number 2 and number 3 long-running processes. And when an exception happened in one, it could inform the other, and then go back and also inform the awaiting task. So Coroutine Scope manages one or more coroutines. It can stop execution when the user leaves that area. And there's a handy coroutine scope that's provided to us as part of our Kotlin KTX library, something called a view model scope that can manage a coroutine within a view model. This is what we'll use in our example. And indeed, I'll have an example in a video that's upcoming shortly. So I hope this animation and overview has been helpful, and I look forward to reading your comments. Thank you.